start there today. So 20 and 21, we're going to get rid of. So we're jumping into graphing logs. So that's why I said you have to know how to graph exponential functions. And I didn't assess you on graphing inverses on your quiz, but this will help you practice graphing inverses. All right, so one thing we have to review is how to change from exponential into a log function and find the inverse. So let's just do that down here before we get started. So if I have y equals 2 to the x, how do I find the equation of its inverse from last class? I switch x and y, right? X equals 2 to the y power. And then I have to change it into log form, right? If it starts as an exponential function, it ends as a log function. Miles, can you join us now on the notes? Do you need a copy of these? These are the log notes. This is like, need to focus so we can get this part. All right, so how do I change from exponential into log form? The base is 2. That makes my log base also 2. I'm trying to free up y, right? So it's the x that comes inside the log and the y that switches places. Remember, 2 to the y power gives me x. So those are equivalent statements. They're just written, one in exponential form, one in log form. We're just past number 20, so like 22 on the set of notes from yesterday. So that is the logarithmic inverse. Y equals the log base 2 of x. So that's what we want to learn how to graph, is a parent log graph. So we're going to use the exponential graph to graph the log graph. So I said, let's make a table of values for 2 to the x, because we already know how to graph 2 to the x, right? I'm going to start at 0. What's 2 to the 0 power? 1, right? And what is 2 to the first power? 2, right? What's 2 squared? 4. And what's 2 cubed? 8. So these are points that we should have been able to graph on our quiz on exponential functions. When I go backwards with negative exponents, all I do is I just make these into fractions, right? So to the negative first power would be 1/2. To the negative second power would be 1/4. So 1/2 and 1/4. So I'm going to graph that exponential function. So we're actually helping to practice graphing exponential functions. So 0, 1, 1, 2, 2, 4, 3, 8, 1/2, 1/4. So there's my exponential function of 2 to the x. And I should also make note that it has an asymptote, right, at y equals 0. So it says, how will this table help us to graph the log function? Isn't an inverse, you just switch x and y? So in a different color, I'll do mine in red. I'm going to graph the log function with base 2. So instead of 0, 1, I want to graph the point 1, 0. So there's 1, 0. Instead of 1, 2, I'm going to graph 2, 1. And then 4, 2. And then 8, 3. So there's that part of the curve. This side of the function is a little bit more challenging. You go to 1/2 on the x-axis, -1. So you're going down pretty steeply over here. So there's my parent log function for 2 to the x, or log base 2 of x. So it always goes through the x-intercept at 1, 0, because the y-intercept was 0, 1. And then if this was 1, 2, I'm just switching that 2, 1. It has an asymptote, so the red graph has an asymptote at x equals 0. Remember, they should be mirror images over the line y equals x. So see how if I hold my pen there, they're a reflection over that line, y equals x. So this is the log base 2 of x. So we've got the exponential function and its inverse. Everyone kind of with me? Log graphs are hard because they're new. So, you know, they're not going to be highly assessed, but would I like you to be able to graph a log function? Yes. Or recognize a log function? They're not as useful for helping solve application problems, but it is part of kind of our skill about logs. So here's a couple more. This one now is base 10. So I'm going to do kind of the same thing. If I graph in black the exponential function for base 10, all I need to do is flip the points to do my inverse in red for the log base 10. And I'm just going to graph 3 key points, right? Our 3 key points should always be 0, 1 for an exponential function. If I plug in 1, what am I going to get? What's 10 to the first power? 10. So 1, 10 for this graph. It's going to be really steep. And if I plug in -1, I get the reciprocal 1/10, right? So this is a really steep black curve that represents my exponential function. So all I have to do is flip-flop those 3 points, and voila, I've got my log function. So base 10, I'm going to go to 1, 0, 10, 1, and then 1/10 is really close here. So there's my red log function, and it goes kind of straight down. It doesn't touch that x-axis. Remember, this is an asymptote. X equals 0 is an asymptote for the red graph. So if you just have 3 key points on the exponential, you've got 3 key points on the log function, and that should be enough. So let's write our domain and range of this log function. What would you say the domain is? What does x have to be? This way, right? X this time has to be greater than 0. And our range is now all real numbers. On your quiz, it was the opposite, right? Because on your quiz, you had, no, I don't have my answer key. On your quiz, the domain was all real numbers, and the range was y is greater than 0. So now we flipped the graph, so we flipped the domain and range. X is now greater than 0, and the range is all real numbers. And my x-intercept is at 1, 0. Am I increasing or decreasing? So as I read my graph from left to right, the red graph, am I going up or down? I'm going up, very gradually, but I'm going up, increasing. I already said my asymptote was at x equals 0. Continuous just means I can connect my 3 points. So there's actually part of the function is here. You know, I could take the log of 3 or 4. They're just not perfect integers. So it is continuous. Discrete means it just goes dot, dot, dot. And the inverse function we already said was 10 to the x. So we've just done log base 2, log base 10. Down here at the bottom, log base 3 and log base 4. So don't be scared of changing the base. All you're doing is changing these 3 key points from your exponential function. So what I'm going to do is the parent graph for log base 3 in black, and then the transformed graph in red. Log base 3, what are my 3 key points? 1, 0 still. And then if the base is 3, wouldn't it be 3, 1? And then 1/3 is down here. So this black graph is the parent graph. What does this red circled function tell me to do? What's the transformation? Up, down, left, or right? In parentheses. Which one is it? So in parentheses with x, it's either right or left. And so if it's a minus, it's actually to the right. So I'm going to shift all of my points just right 1, and then I've got my transformed log graph. And I would have an asymptote now at x equals 1 instead of at x equals 0. So if you're moving to the right, your asymptote is also going to move to the right with your graph. All right, so in this last one of the notes before you try some guided practice, I'm going to do the log base 4 parent function first, and then I'm going to do my transformation, I think, in red. So base 4, the only thing that changes, I still have an x-intercept at 1, 0. I'm just going to go over 4 this time and up 1, right? Just like 10 to the x, I go over 10 and up 1. And then 1/4 is going to be really steep still in this direction. So there's my parent function. Those are the 3 key points that you'd want to graph. What does this transformation do, this +2 right here? Up 2, yay. So I'm going up 2. So 1, 2, put a dot, 1, 2, put a dot, and 1, 2, put a dot. So I just went up 2. My asymptote didn't move, right? My asymptote would still be at x equals 0 because I didn't move left or right. So maybe we've kind of got the idea a little bit of graphing